I hope you can see the slides.
Yes.
This time around, we are going to talk about pesticide formulations. In what form, pesticides are delivered. Things like common salt. Do you know what form it is? How we buy it? Common salt. Pane angade kuattempt.
Sorry, Matichi.
Common salt yatotenga, in what formulation is it? In what form?
Granular, solid,
Yeah?
solid,
Okay,
granular.
solid. Uh, Washing liquid yatozenza kitchen here.
Powder,
Huh?
powder.
It can be powder or what else?
Liquid.
Yeah, it can also be liquid. So these are the things we are going to talk about. Aditika.
Uh,
Yeah, we are not going to talk about something which is very complicated. So pesticide formulations. Formulation is the form in which the pesticide is sold for use. Pesticide consists of two things maybe: active ingredient and inert materials. So there are some materials which are part of the pesticide. Concentrate, that is the part of the total formulation made up of the active ingredient expressed as a percentage of weight and is stated on the label. What are the common formulations? You have already given me some examples: liquids and solids.
we have EC,
Right. We go into inert materials. What are they? Which are part of the pesticide. These are adjuvants or additives in low amounts that improves or enhances storage or handling of active ingredients. Surfactants, we have got spreaders, stickers, emulsifiers, and wetting agents, which could be part of the pesticide. Anti-drift agents, color odor additives to discourage ingestion, antifreeze or other stabilizing chemicals to promote storage. So you can have other things which are added to the pesticide. We will talk more on them later on. Active ingredient is a single active ingredient is sold in various formulations. So what are the types of pesticide formulations? And some of them we are going to focus on them. Basically, there are four. We've got solutions, which are liquids anyway. Emulsions, these are liquids in broad terms. Then we've got dry formulation suspensions. Then granules, which are actually solids. Now we are going to start with solutions. We can have water soluble concentrate, and soluble powder. Right? These actually dissolve in water to form the true solution. For example, herbicides may be formulated as soluble concentrate SC, soluble powder SP, or a soluble liquid SL. Water is the carrier. Herbicides, for example, ammonium salt or mineral salt. This could be the formulation. Agitation may not be necessary to maintain herbicide solution, or it could be an insecticide. For example, arsenal, Roundup, and Todol. Now, for solutions, mixing, you may not require to do agitation. But sometimes when you do agitation, we want to make sure that the pesticide is actually dissolved. These are easy to dissolve. So on glyphosate, you may find that it is written SL on the pack. Paraquat 20 SL. So SL means soluble liquid. SL soluble liquid. Glyphosate 360 SL, it means soluble liquid. That is the formulation. Pendazone or Basagran 48 SL, it means soluble liquid. Right. Then we have emulsions or emulsifiable concentrates. Emulsions are like chemical bridges between droplets of oil and the body of water. So they are like bonds between oil and water. Linear molecules with hydrophilic water. When you say hydrophilic, we are saying water-loving head, and lipophilic, oil-loving tail. When the oil and water are mixed, they congregate at the interface between two liquids. This mixture gives a milky appearance or whitish stuff. If you mix water and that pesticide, if you get that milky appearance, you are dealing with emulsifiable concentrates. This usually happens with the growth regulator herbicides, ester, and it could happen with other insecticides as well. So you may find on the label it's written EC, meaning emulsifiable concentrate. Preforan, I think it's a herbicide, 30 EC, it means emulsified concentrate. Superco 360 EC, that EC represents emulsified concentrate. This is a herbicide, I think it is Araclo or Propaclo, 960 EC. That EC note, it is representing emulsifiable concentrate. All you need to know is what are the characteristics of the emulsifiable concentrate. I said if you mix that substance with water, there's going to be a milky sort of appearance, after mixture. Proper quizafop, it's a herbicide, it's an EC again. Agile, EC again. Right. We move on to liquid flowable, liquid suspension formulations. Liquid flowable formulations are highly viscous, which means if you wanted to pour them out of the container, it's very difficult. They are not easily poured, so it can be a bit, disturbing, to work with such products. It's not easy. A slurry or a paste formed by wettable powder and water. So sometimes you have to do this paste before you actually mix. Liquid flowables separate during storage. Particles settle at the bottom of the container. This is one of their problems. Now, if you take atrazine, for example, which is a flowable, if you don't shake the container, you may leave a lot of atrazine, in the container. So you need to shake it, then you try to measure it. I can't remember. There's also another post-emergence herbicide, I will check, which is also difficult to pour. So this requires careful mixing. So the flowable, liquid flowable, or liquid suspension formulations. Atrazine 50, sometimes they actually write flowable so that you note the formulation. Gesaprim 500 FW, meaning flowable. Gesagard, I think it's used in cotton, 500 FW on the label. It means flowable. Gadomil 500 FW, it means flowable. Gesapax 500 FW means flowable, referring to the formulation or the state in which the product is sold. Now we move on to dry formulations. So what we have been talking about are liquid formulations. Granule, the G. This is ready to use mixture of a small amount of active ingredient with inert carriers. Pesticide is absorbed into the granule. It can be used for soil treatment. It may not be mixed with water. The advantage is that this minimizes drift, so it can minimize contamination with the end user. It's ready to use, but of course, the disadvantage is that large quantities may require expensive transport. At some point, we used to have a granule atrazine, which was brown in color. you didn't require a sprayer for this. I've actually used it. You could just broadcast it as if you are putting fertilizer. After that, if it rains, then the atrazine would start killing the weeds. It was nice because you could not, it didn't require this water and so forth. But in this country, they've stopped manufacturing it. I don't know why. Maybe it's expensive. So granule, okay. Then pellet, it's similar to granules in that they are ready to use, may be applied by hand or machines, also used for soil treatment. Drift is not a problem, so they are easy to work with. So we have reduced application hazard. Rat poison is usually delivered as pellets. Wettable powder, WP or W. This is finely ground solids. Mineral clays containing active ingredients. Dry formulations look like dust. This can be risky. You need a mask. Wettable powders form suspensions in water and form true solutions. With these ones, when you are mixing with water, you really need good agitation. You need thorough mixing. A disadvantage is that they can be abrasive to pumps and nozzles. The other one is that you really need a mask because there is an inhalation hazard during mixing. In fact, I don't like to work with wettable powder, WP or W, insecticides or whatever herbicides, because the chances of getting contamination are very high. Example here, tribunal, WP. Sengo, which is the herbicide used in soybean. At some point, it used to be a WP, a wettable powder. But now it's a liquid formulation. It can be SC. Atrazine, we now have flowables. But at some time, agriculture used to sell WP. Probably it's a long time ago when agriculture was selling this product. This is their side, agriculture. Diuron 80% WP, which means wettable powder. Then soluble powder, it's SP. These form true solutions. Agitation may not be necessary. Non-abrasive to equipment, but there's a hazard because it's a powder. Inhalation hazard is there. So you will need a mask. Otherwise, these powders, they are not easy to work with. Then we have got what is known as water dispersible granule or dry flowable, WDF. DG or DF, WDG or DF. This can be mixed with water, readily disperses in water to form a suspension, but constant agitation is required. But unlike the soluble powders, these are less of a hazard, so there's no inhalation hazard. So it's safe to do. It's a bit safe to work with the water dispersible granules or dry flowable. But they can damage the equipment. It's a disadvantage, abrasive to equipment. We have Diron 80 DF, then nicosulfuron 75 WDG. Now I want to talk about spray adjuvants or additives, surfactants, which are added to improve either herbicide efficacy or it could be insecticide efficacy. You may have activators which improve pesticide efficacy after spray has contacted the leaf surface. Utility adjuvants which improve the ability to get the pesticide to the leaf surface. Activator adjuvants, this is water is a polar molecule with negative and positive charges. Water molecules are strongly attracted to each other than the surfaces they are in contact with. This is the property of water. Water tends to run off the surfaces. So you may need wetting agent which can reduce surface tension in water. Droplets become flatter on the surface. Surfactants, e.g. soap, but there are special surfactants which can be used. This is soap. It may act as a surfactant to improve herbicide performance, but it doesn't necessarily mean that one has to mix herbicide with the soap. Maybe you can damage your crop. Here I've got a diagram showing a droplet. The first one is in contact with the surface, displaying a small surface area and can easily roll off. But if you put a surfactant, you can flatten it so that it can stay on the leaf. Stickers can be included in the pesticide to help the pesticide stay on the leaf surface after water is evaporated. The herbicide can be efficiently absorbed, or it could be any other pesticide for that matter. Humectants, they retain moisture or absorbs water vapor. They reduce evaporation, prevent the herbicide or pesticide from crystallizing, increase absorption of the herbicide into the leaf. So these are some of the materials which help to make the pesticide efficient in killing the pest. We also have something called the penetrants. Surface of a plant is a waxy cuticle. It can prevent the pesticide from entering the plants. So you need oil-soluble penetrating agent, which allows the pesticide to pass through the cuticle. Drift control. When you are applying some pesticides, there's a chance of having your droplets to be carried by the wind in a drift. Especially small droplets, can be carried by the wind. In order to reduce this effect, you need long chain molecules which can reduce drift. So there are some materials which can be mixed with your pesticide to reduce drift. Now, there are some herbicides, particularly glyphosate. It can produce a lot of foam during spraying. Even when you are measuring, you may not know how much you want to apply. It's difficult to measure with a lot of foam. So you can add deformers to reduce this problem. Colorants. Maybe you want to see where you are spraying, you can add a colorant so that your spray becomes visible. You can then determine the spray pattern. These are added, these are extras to make work easy. So this is it on pesticide formulations. I've tried to be as direct as possible, tried to simplify it. So I will stop presenting. Right, so this is it for today. Any issues? What I'm going to do is to send you some probably from tomorrow. I will start sending you some sort of assignments so that when you read, you try to solve some of the problems. But I will be marking these assignments in the 3rd week when you will be revising for your exam. Probably there could be one day when we may require you to come here so that you may see some of the things. We may do some practicals so that you become familiar with some of the things I will be talking about. We can just do it in half a day. Just a day out of, from this space we have. Aro, are you there?
Yes, Prof. We are here.
Panogona kunge paine mazita chete vanhu vabuda vakuinda kubasa.
Tiripo yedu.
Vozora vakupedza lecture yacho kuti vanhu havasi kubuda. Saka I think tosakana futi around 9 mangwana.
Okay, Prof.
I will send you what we will be talking about. So you have your notes. You also have, recorded teaching videos. You can just, probably you try to play the videos and so on. So you should be having enough resources.
Okay.
Yeah.
Okay.
Where we are going, I think it's now more interesting, part of this module. The other parts, everything will be interesting as we go.
Okay.
Yeah, because some of the things, when you work, you may end up, using them a lot. Muri kusenza mese
No.
Prof, taitofunga kuti your timetable iri kuclasha manje nebasa everyday une wakanonoka.
zvimwe zvandogona kuita ka. It depends on you. Ndogona kungokupai teaching video.
Anokudzidza kuri right. Ameno kuti 5 hamusi comfortable nayo.
5. Inai stay ndinotonika.
All right.
Saka 5 pamwe ndendandosvikawo kumba.
Yeah. There's no problem. Regai tishande nezvozvo.
Okay. 5 ndendabuda mara.
Regai tikumbire 8 futi is too early for you.
Saka I mean, if we work like what we are doing, I think it will go right.
Yes.
Okay.
But resources, they are always there. All right, so we will meet tomorrow. Then we see how far we can go.
Okay. Thank you.
Okay. Thank you.
All right.